stealth technology has become an essential cornerstone of every major military power. But with each generation of aircraft, engineers are forced to make bolder, more ambitious choices. The U.S. Air Force's latest strategic bomber, the B-21 Raider, is one such leap forward. It represents decades of relentless innovation in both stealth and combat effectiveness. And today, we're going to reveal how this next-generation aircraft is designed to meet the challenges of future warfare. Since the introduction of the first jet bombers in the mid-20th century, military aviation has advanced at breakneck speed. Each new generation grew more sophisticated, more secretive, and deadlier than the last. Yet stealth itself wasn't always embraced. In the 1990s, many critics in the United States dismissed it as an unnecessary expense, urging defense cuts. But history proved otherwise. Stealth has completely reshaped intelligence gathering and combat operations behind enemy lines. Still, it hasn't been a flawless solution. It came with trade-offs in speed, aerodynamics, and cost. Take the legendary F-117 Nighthawk and Northrop's B-2 Spirit. Neither carried afterburners, meaning they were limited to subsonic speeds. Sure, supersonic flight sounds exciting, but a deafening sonic boom paired with a glowing heat signature on enemy radars defeats the entire point of stealth. Add to that the massive fuel demands of afterburners, and the math simply didn't work. Another major hurdle was stability. Early stealth planes were inherently unstable in flight. The only reason they could even take to the skies was thanks to digital fly-by-wire systems, which relied on computers making split-second adjustments every moment. And then came the coatings, special materials designed to absorb radar waves. Developing these coatings was a challenge of its own. They had to reduce radar visibility without adding weight or draining the defense budget. Reapplying them after every mission cost U.S. agencies and taxpayers an eye-watering amount. That's why early stealth pioneers leaned heavily on design over materials. Roughly 85 to 90% of radar signature reduction came from the aircraft's shape itself, while only 10 to 15% relied on absorbent coatings. One of the first public hints of a secret American stealth project appeared in Defense Daily in 1975, reporting on what was then called High Stealth 2. A few years later, in Jane's All the World's Aircraft, reports surfaced of Lockheed's Skunk Works developing a small stealth fighter with dramatically reduced radar, infrared, and optical signatures. The secrecy surrounding the F-117 Nighthawk was legendary, arguably even greater than that of the B-2 Spirit. Still, whispers and rumors eventually forced the Pentagon's hand. In 1988, they released a blurry, grainy photo of the F-117, just enough to confirm its existence, while carefully hiding its true design. By contrast, during the B-2's development, the Air Force was less obsessive about secrecy. The program, known as the Advanced Technology Bomber, ATB, was gray rather than completely black. Perhaps because of this, the B-2 Spirit became the ultimate icon of stealth aviation. For much of the world, the Spirit itself came to define the very meaning of the word stealth. When the B-2 Spirit was unveiled to the public in November 1988, it didn't just arrive, it rewrote the rulebook. Its radical flying wing shape, unprecedented use of composite materials, advanced avionics suite, and mission-tailorable systems pushed aerospace engineering to new limits. Building the Spirit was a national effort. Roughly 6,000 companies, 40,000 people, across 46 states, and a dozen technical disciplines, from integrated 3D design to manufacturing and large-scale composite molding. The B-2's combat debut in 1999 during the Kosovo campaign was a turning point. In the first 8 weeks of U.S. involvement, B-2s were credited with striking roughly 33% of targeted Serbian positions. It also broke new ground as the first aircraft to employ GPS-guided Joint Direct Attack Munitions, DAMs, smart bombs that replaced the carpet bombing approach of the 1991 Gulf War. The Spirit went on to serve across multiple theaters: Afghanistan during Operation Enduring Freedom, Iraq in 2003, Operation Odyssey Dawn, and numerous precision strikes against ISIS targets, often coordinated with MQ-9 Reaper drones. By November 2001, when the Air Force updated the B-2's service life projections, leaders acknowledged the need for a successor bomber before the 2040s. That kicked off the Next Generation Bomber (NGB) program in the early 2000s. But ballooning costs and expanding mission requirements forced the NGB's cancellation in 2009. Long-range strike capability remained a top priority, so the effort evolved into the Long-Range Strike Bomber (LSB) program, aimed at delivering a new strategic bomber for the U.S. Air Force. The LSB was intended to replace parts of the existing bomber force, notably the B-52 Stratofortress and elements of the B-1 Lancer fleet, while complementing the B-2. Though the B-2's service life was projected to reach into the mid-2040s, the Air Force later decided to retire the B-2 no later than 2032, and the B-1 before 2036, leaving the B-52 as the backbone through the 2050s, thanks to its lower maintenance costs and flexible payload options, including nuclear cruise missiles. In October 2015, the Department of Defense awarded Northrop Grumman the contract to build the 21st Century Bomber. The program's initial price tag was $21.4 billion, with future estimates swelling toward as much as $80 billion. Cost competitiveness, particularly against Lockheed Martin and Boeing, was a decisive factor in Northrop Grumman winning the contract. By December 2022, the estimated unit cost for a single B-21 was about $700 million, far less than the more than $2.1 billion per B-2. The Air Force's target: a fleet of 100 Raiders by the second half of the 2030s. From a glance, the B-21 may look like a smaller B-2, and in stealthy flying wing design there are only so many ways to reinvent the wheel, but the innovations lie in the details. According to Air Force officials, the B-21 will operate at a higher service ceiling, improving sensor line of sight, simplifying communications, and boosting pilot situational awareness. Flying above 50,000 feet should also reduce the risk of interception by enemy fighters and their early warning aircraft. Secretary of Defense Lloyd Austin has argued no other long-range bomber matches the Raider's combination of reach and efficiency. It won't need to be forward-based in theater, it requires less logistical support, and it can threaten targets from farther away, giving commanders more options to thread through an opponent's long-range anti-access/area denial defenses. That extra unrefueled range means the Raider can loiter and hunt inside contested airspace without wasting precious mission reserves. After multiple public photos surfaced in recent years, experts have applauded the B-21's sleek, low-observable design. The airframe shows broad, seamlessly blended surfaces with minimized protrusions and elevation changes. Intake ports, a long-standing headache for stealth engineers, are tucked into the flying wing inlets in a way that marks a meaningful step forward from the B-2. In short, the Raider looks familiar at first glance, but the refinement and engineering advances under the skin make it a clear evolution, and in some ways, a revolution, in stealth bomber design. Across the Raider's fuselage, you'll notice something striking: no heavy panel seams in sight. Decades of progress in material science and advanced computer-aided design have allowed Northrop to craft massive composite structures without the need for multiple joints. The result? A body so seamless, it's the perfect canvas for a fresh layer of radar-absorbing material. Its exact formula kept more secret than the recipe for your favorite diner's signature dish. Even before the first Raider prototypes took flight, Northrop had already upgraded the B-2 Spirit fleet with next-generation coatings called AHFM, alternate high-frequency material, a stepping stone toward what the Raider would eventually wear. When Northrop revealed the B-21's windows, reactions were mixed. The front panels looked normal, but the narrow side windows, sharp and slit-like, sparked debate. Their unusual shape is no accident. It's a stealth-driven design to minimize radar detection. The Raider's biggest design challenge? Recessed air intakes. Northrop has been perfecting this since the experimental Tacit Blue in the 1980s, when engineers struggled to separate turbulent airflow and hide reflective engine fans without starving the engines. The B-2 used large, scalloped intakes. The B-21 goes further. Its intakes are flush, seamless, and deeply blended into the wing. What engines power it remains classified, though many point to the Pratt & Whitney F-135, also used in the F-35. Photos from its November 2023 flight revealed a smaller weapons bay, suggesting the Raider may carry just one massive ordnance penetrator instead of the B-2's two. But here's the trade-off. The Air Force plans for 100 Raiders, compared to just 19 B-2s still flying. What's more threatening, 2 bombs from a Spirit, or 100 Raiders striking in unison. And the Raiders' arsenal doesn't stop there. It's built to launch the AGM-181 LRSO nuclear cruise missile and could even deploy swarming drones, giving it unmatched flexibility. But the B-21 isn't alone. It's part of the U.S. Air Force's long-range strike family. Alongside it are the upcoming NGAD 6th-generation fighter and fleets of collaborative combat aircraft, CCA, drones. The Air Force plans to buy at least 1,000 CCAs, meaning that by the mid-2030s America could field a 100 B-21 Raiders, hundreds of next-gen fighters with F-35s, over 1,000 drones. If that's not the blueprint of the future air fleet, what is? So the question remains, will the B-21 Raider surpass its legendary ancestor, the B-2 Spirit? Share your thoughts in the comments below.